I came across this great question on Quora. As an experienced software developer, a non-game developer, how can I get started on game development? So this idea is that you already have knowledge in programming and then you want to expand into the game development market because games are a different beast. In a lot of cases, they are lighter and easier and you can get interesting things to happen in them very quickly. But at the same time, they're also incredibly complex, very fragile, and where you have to be an incredible expert in all sorts of things in order to get particularly good at it. Now, that's not to say anyone can make a really great game and be successful, whether they're junior or middle level or senior or whatever they are. Okay, so let's actually just dive into this. I'm going to go into the creation of a game, a very simple game concept, and I'll be explaining some of these concepts along the way and how it differs from what we might see in programming. So to start out with, I've got Unity up. Unity bases itself on C#. If you're more into C++, you can follow Unreal. Unreal is going to have some different vocabularies. For instance, most of the components are scripts that you add onto something treated as an actor. In this, we're all very component driven. So I have this empty scene here, and if I say game object create cube, a game object 3D object cube, it puts a cube floating in the scene that I can now play the game, and it's just sitting there. Now the game is running. It's running at like 600 frames per second. So keep that in mind. 600 frames per second. This is a huge difference from what you see in a standard application to what a video game operates at. That frame rate right there, that is one of the biggest differences because most web pages can be stagnant until something happens. Most text-based consoles have to show absolutely nothing until the user types something or the program spits something back out. That they can just sit there idle without something repetitively showing up on the screen. This is much different. So on this one, if I want to see what this looks like, if I want to see what's happening here, I can also click on the rotation here. This is in the transform. I have the cube selected down here, and I can rotate this object around. You see me dragging this around? 360 is that point where it's gone all the way back around to the beginning again. Okay, so this is moving around. Now, something else I can do here, I can add a component like a rigid body. Now, I'm not going to add it yet, but a component is basically a single C# script. It can have more scripts and code underneath that are supporting it. But a component is a single script that gets added to your object and gets certain functions on it called, like a start function, and then you have access to the game object. You can get information about it, like where is it positioned? What other components does it have? Does it have a rigid body? And the rigid body by default gives it things like gravity. It makes it understand its physical understanding within the world. So as soon as I add this, it falls. Gravity is on it. And if I look at the Y position, that's making its Y position fall farther and farther and faster. 200, 300, 400, 500, 6, 7, 8, 9, 10, 11, 12, 13, 14. It's getting faster and faster. Anyway, so I'm going to pause that, or I'm just going to stop the game. So the rigid body is also gone. That's another thing to understand. So this game was operating at 717 frames per second when I stopped. Now this updates when I move my mouse around because it's highlighting things, it's changing things going on in here, and it's operating in the editor, which doesn't matter as much to the frame rate. So things can take longer and be sluggish, and they don't care. Okay, so on this one, I can add some of my own scripts to it. Like, let's say that I right-click down here in my assets folder, and I say right-click, create C# script, and I'm going to call it rotate. So I've got this script called rotate. Now inside it, reload, inside it, it's got code. So what happens when the game object first appears in the game? For a lot of game objects, that's when the game first starts at all. They're already there in the scene. But the update will happen every single frame. So let's say I want to rotate the object. It takes 360 degrees to move around. So let's try this. Transform. If you remember over here, if I actually select the cube, transform is the name of the component that has its XYZ location, its rotation, its scale. So its position within the world and its perspective of the world is there, held there. So I'm getting the transform, and the transform is a special case. Every single game object has it. So it's always available. A lot of the other components are not always available. But transform is. It's one of the unique cases. It's always there. Okay, so transform dot rotate. And I'm going to say vector 3 dot up, comma 1. Okay, so this is telling this object to rotate up. What do I mean by up? Well, think about this. I'm pointing up. How could I spin around up? Like this. The axis is up. If I were spinning right, I would be spinning along this axis. Or forward would be like this. So when I say vector 3.up, it's this axis going up and down that I am going to be spinning around on. If I go positive, I'm spinning one direction. If I'm going negative, I'm spinning the other. Okay, so let's try this in code. I've got this rotate script. And now I'm going to drag the rotate script onto the cube. Not here, but inside of the inspector. And suddenly it's just here. It's part of it. If I hit play, remember, every single frame, it was moving 1. Now, it has to get to 360 degrees to finish its rotation. So once it does that, once it's finished its rotation, it's doing that, but it's doing it so fast because it's not operating at 60 frames per second, it's operating at 600 frames per second. We need to slow this down because my machine is pretty powerful. A lot of other people might be running on a weaker machine, and still there are going to be people that beat me out from my game system any day. And so we need to make sure that the frame rate feels right because this code is constantly updating the rotation of this object every single frame. So a concept that immediately comes to mind is delta time. Delta time is the amount of time that has passed since the last frame. So 1 times time dot delta time. Oh, times. 1/2 times time dot delta time. So when this runs, the idea is delta time will basically get to 1 second after 1 second has passed. So if we're operating at 60 frames per second, delta time will be 1/60th of a second. All right, so let's try it out. Or what was that, 0.016, I think? All right, so now let's try this. With this, we end up with a stable frame rate of rotation. Now, here's one of the interesting things. If you look at this, it's still spinning right now. The rotation is moving. I actually didn't even recompile the video game. Unity did that for me. That's one of the cool features about Unity. So it's changing live. Now, inside of here, this is happening, but this is very slow. Now, I could come into here and I could change this to 10 to rotate 10 degrees every second. So when you multiply something by delta time, it's basically per second. So that's how far it's going to move per second. Your speed is now, if I told it was 10, it's 10 degrees per second. So now it's operating at 10 degrees per second. So 20, 30, 40, 50, 60, 70, 80, 90. Well, it's going backwards now. Okay, and I still haven't stopped the game. This rotation is happening. But something else that we can do with the video game is that we need to make sure that these variables are exposed. So inside of Unity, for instance, we create our public field. So public float because video games operate on floats, not doubles in most every case, because of the fact floats take less processing power. And quite honestly, the amount of precision you get on a float is just fine for video games. In fact, for most systems that you're going to develop, a float is going to work just fine, and you're not going to run into issues at all. So let's say public float speed. So I have public float speed. And now inside of here, I have a speed variable. I can change this to whatever I want. Let's just change it to 10.42. Actually, let's change it to something that'll make an impact when I do this next thing. 45. So that's 45 degrees per second. But the speed is still operating at 10 frames per second here. What I need to do is, instead of have this hard-coded, I'm going to pass in speed. So I'm kind of doing that thing where I'm doing the beginner programming thing here, I guess. But I'm changing it out with speed because I want to get it from this field. Different game engines operate in different ways. So this just finished executing, and now it's moving faster. That is a much faster speed now. It is moving 45 degrees per second. And what's interesting is I can now change this and make it operate even faster. So now it's spinning even faster. It's moving 160 degrees per second, or 360. Okay. So this is a component attached to this. If I wanted to mess with other things inside of here, I could manipulate them. I could change them. There's other things that I could add to this. Like, let's go ahead and put another object in the scene while it's running. I'll put in a cube, 3D object, cube, and it's staying put. This is operating on another principle of game development. The objects, they're colliding with each other, but that doesn't matter because none of these have physics. If I were to let me take this game object that I just added and drop it down a little bit. So that was actually surprisingly clear on that one. Okay, so cube, and now let me add rigid body to this. So now there's a rigid body on this. This object keeps spinning, but it doesn't really have much friction or anything with the game object below it. If I were to take this object that was below it and start to move it around, you can see it's falling on it and pushing it up. Look at that. And that is a very simple little idea of this game. Now I'm operating that by mouse by just affecting these, but I could write a piece of code that influences this as well. So let's make another script here. While my game is still running, I still haven't stopped the game, by the way. Create C# script, and we're going to say jump. All right, I'm going to double click on jump. And in the update, I'm going to take advantage of a couple things right now. I'm going to say public float force equals 10F. I could just say 10. It translates to 10F anyway. And then in the update, I want to check to see, did a user press a button? Now, there's three things that you have to choose from for the button press. And that is another thing that's important to think about for games. If input dot get key down, there's also get key. So get key down and get key, the difference between these is whether you have something that's going to fire every single frame if a user is pressing a button. So if I'm pressing left or right, I am expecting that every single frame it will be checking that and making my character move farther to the left or to the right. But if I'm shooting, if I'm launching an object into the air, throwing an object, I expect that when I press the space bar or the control button, that happens when I press the button, but only once. And then I have to let go and press again, so I'm tap, 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 tap to get it to repeat fire. So in this one, get key down returns true during the frame the user starts pressing the down key. So it only happens once when you press the button down. If I choose get key, it's the opposite. It says this will happen while the button is held down, any frame that it gets to. So I'm going to choose get key down, so it's just that first time. And I'm going to say keycode dot space. Oops. So if the user presses space, the space bar, and this is checking every frame for that, if the user has pressed the space bar, then we are going to say get component dot, get component, and I'm going to ask for the rigid body. Now the rigid body, so I asked for the component rigid body. Now normally you would save this to a variable. You wouldn't ask for it every single frame because you need things to operate fast. You want to store a reference to it the first time you ask for it. So we're asking for the rigid body, and I'm doing this as a shortcut, and I want to say add force. And I'm going to say vector 3.up. We're using up again, but times force. So whatever our force is, it's going to say, well, push that up. The rigid body gives it physics. It makes it want to drop down with gravity. So I've got this jump script in here. I'm going to return to Unity, where surprisingly this cube is still just sitting there and working. It seems to have shifted a little bit, and I think it'll just continue working like this anyway. So I'm going to take my cube script with the rigid body, and I'm going to add another script to it. This one was the jump script. So think about this for a second. I have added one component that adds that feature capability of this object now can spin, and another one that is going to give it the jump ability. So when I press space, it jumps. Now, nothing is happening here. You can't really see it because 10 is not that much force. Let's try 50. All right, let's try it out. Space. Oh, a little tiny hop there. Now, let's try 100. All right, and space. It keeps adding it. Now, that's another thing to think about. When you think about Mario Brothers, when you think about these objects in physical space, you think about the jump button and the fact that it just seems so intuitive that when you press that, it's supposed to only happen when it's on the ground. There's going to be a lot of things that when you start getting into game development that it feels like, well, it should already do that. Almost like when you first start concatenating strings, that there's that natural assumption that it's going to put a space there because you just tied this word together with that word. And so there should be a space there. But if you want to detect if something is on the ground, you have to come up with a way to do it. Like, for instance, is its Z stable? Is it the same Z level as it was during the last status? Do you know what the Z level is? What the Y level is? How high it's supposed to be for the ground? Do you have a collision detector that is detecting that it is currently touching a collider on the ground? There's a lot of ways that you can do it, and you usually want to choose the way that it takes the least processing. Okay, so I've got that jump script, and maybe I'll put another one in. Or, well, whatever. It's jumping around, it's working. If I press it fast enough, it's kind of like Flappy Bird now. Maybe a little bit. Oh, yeah, actually, so if I change that to maybe 150, I've kind of just created Flappy Bird now. Oops. Here. There's Flappy Bird. Now I just need some objects that are moving to the side. And that's it. All right, so that's kind of the basics of how you create Flappy Bird. Anyway, so the thing is that you're constantly creating these little components that interact together. Your code will be operating every single frame against systems, or against whatever it's running against. So you've got an update, and that object will run 60 times per second. If I were to take this rotate script and disable it, it no longer executes. That jump script, that's still operating, but it kind of felt almost like the game got quieter when it stopped spinning. And that is another concept entirely. And maybe you didn't notice it, maybe you did, but the thing is that there are things that you put into the game that breathe life into it. Where if everything is just stagnant, if the buttons, if all they do is just you click the button and it just disappears, and that there's no animation cycle or anything on it, it's not as satisfying as when you click a button and you see it pop in, or in a lot of the games you see them kind of bubble shake a little bit as you click them, and then they swoop out, stretching a little bit as they do. It's surprising how many little tiny things like that actually add up to make a game feel better. So when you're programming, there's a couple things in this, just on the technical side, that you need to figure out about how you control the code inside the game engine. But what really makes a great game developer is that ability to tie the art into it, the feel of the game. That you're thinking of this not just in making something happen, but how do you make it happen and really pull the user into this world? You add little bits of effects here and there. You add little tiny ways to things that land. So your character lands, and after they've jumped up off, or they've jumped on off of something that's just a little bit too high for them, like they have their height that they can jump normally and they're just fine, but a little too high, and it signals that, oh, there was something a little bit scary about that. So the camera shakes. That moment where you impact the ground. If you were moving with enough speed at that moment, then you apply that speed as a force to the camera and have the camera on a joint that just suddenly makes it shake around a little bit until it stabilizes. And suddenly you change the whole effect of the game. There's so much you can do with that. So when I turn this back on, it's really minor, but now the game is alive. In fact, there are 3D systems. There are 3D holographic systems that are available out today that if they are not rotating, if they are not looking at something that is moving, your brain just immediately can tell that, well, that's just 2D. But if it's still moving and rotating, even though it's on a 2D screen, you feel like there's a physical object there. Every game system has stuff like that, the medium that you are playing that game in. And so every time you are writing code, you should be thinking about, how does it feel to do this? It's very easy to get caught up in architecture when you come from a professional programming background, that you know how to do these different types of architectures. You want to write all this code to make things happen. But in the game development side, you really need to get into the art of it as well. So another thing about this is these scripts that I added, they added features that a designer who doesn't know how to program can come in and take advantage of. I could write code that just entirely manages everything. It creates a game object. It puts a cube mesh onto it, and a collider, and a renderer. So it draws this and it shows this. And I can control everything from code without having any components at all. That is possible to do in Unity. So, but if I did that, there'd be no designer capability. No designer could come in and do this. And so if I got new art, I have to put it in. If I wanted to change the way a character moved, I had to do it. If I wanted to edit the way a level worked, I would have to do it as the programmer. And this takes huge amounts of work, and you want to be able to allow your games to be operated and controlled by a team of people. Even if you're just starting out on your own, you're going to save yourself a lot of time and headache by learning to use the tools that come with it. Don't keep reinventing the wheels. That is going to hurt. You'll learn a lot. You will learn a lot by reinventing the wheels, but your team will suffer for it in many cases. All right. So hopefully this has been educational and given you some ideas to think about and how to get started. All right. Talk to you later.